So here we understand the concept of projection. So the meaning of projection is to project any of the object on the projection planes we are calling as a projection. Suppose we are sitting in a room and we have the vertical wall is normally treating as a vertical plane and the floor is treating as a horizontal plane. There are two side walls also. To them we are considering as a auxiliary plane which are perpendicular to both VP and HP. And if we are standing in a room and there should be some light source falling on us, then we are getting some shadow on the maybe on the floor or maybe on the vertical wall or maybe on the side walls. So means we assume this shadow is normally treating as a projection of our body. Okay? So in terms of graphics, if you are talking, that means that from the contour of the body, if we draw the lines, to them we are calling as a projectors, and these projectors are meeting on the projection planes. And if we join these points, projected points in a sequence, then we are getting the projection of the object. So there are four different kind of projection. First is called the orthographic projection. So in the orthographic projection, we have seen that the projectors are parallel to each other and they are perpendicular to the plane of projection. So here there are two planes, vertical plane and the horizontal plane. So in short, this horizontal plane is representing by the HP and this vertical plane is represented by VP. So these are called the plane of projection, HP and VP. Here we have a three-dimensional object and we have seen that there are different points on the contour of this object. P, Q, R and S on the front face or on the back face. We have the points T, U, V and W. And these are the contour points. And from these contour points, if we draw the lines, so these lines we are calling as the projectors. Yeah, it is written there visual ray are parallel and perpendicular to the plane. So these lines are called the projectors and these projectors are perpendicular to the plane of projection. So here we see that P and T point are coinciding. So here T and P point is coinciding. Similarly on the second corner, U and Q point is coinciding. Then W and S point is coinciding and R and V point is coinciding. And when we join these points in sequence, so we are calling this as a projection of this object on the vertical plane. Similar type of projection we are getting on the horizontal plane. In this orthographic projection, it is important to understand that the projectors are perpendicular to the plane of projection. Either it may be a HP or it may be a VP basically. And we assume that the light source is at the infinite or the observer is standing at the infinite so that all the projectors are parallel to each other. So this is normally called as orthographic projection. In the orthographic projection, one view is not sufficient to completely describe the features of the object. So we require at least two views or maybe more than that to completely specify the different dimension and feature of the object. So here in this first figure, if we see that only this PQ dimension and our PS dimension are shown in this projection. We don't have any idea about the third dimension called depth dimension, that is TP. So we have to take one more projection on the HP. So with this HP we have third dimension. How much is that dimension basically? So at least two views are sufficient, and if we require more than two view on the side planes, then we have to specify some more feature of the object. So this is the basic principle of orthographic projection. If we see the oblique projection, then in the oblique projection we have seen that the projectors are not perpendicular to the plane of projection. So here we see the same object is placing, and if we see that all the projectors are parallel to each other but they are not perpendicular to the plane of projection. They are making some angle with the plane of projection. So we see that whenever we are projecting the object on the vertical plane or maybe on the HP, so we are getting the complete description of the object, means all the dimensions are clearly visible to us about this PQ dimension. Then PS dimension means its length, width and how much is the depth of particular object. So only one view is sufficient in this kind of projection. So that projection normally we are calling as a oblique projection, means when the projectors are not perpendicular to the plane of projection. So that type of projection we are calling as a oblique projection. The third angle of projection is the isometric projection. So in the isometric projection, we have seen in this figure that we have considered a block and there are three axes, axis of x, axis of y and axis of z, and this O point is called the origin of these axes. So when we orientate the body in such a orientation that the angle between x and y the angle between y and z, the angle between z and x is 120 degree. Then, and the projection of this body on the vertical plane we are calling as a isometric projection. The fourth angular projection is called the perspective projection. In the perspective projection, we have seen that this S is the observer eye, or we can say the light source actually. So here we have seen that, and this is the AB line which normally we have to project. And this is the vertical plane. On this plane we have to project this line. So here we have seen that because light sources we have to locate first, and then with respect to that light source we have to take the projection of this object. So this the projection of this AB line on this vertical plane is A dash and B dash, and we see that this is reduced in size. Similarly, if we have taken the AB line in front of the vertical, this is the vertical plane in front of the vertical plane, and this is the observer eye, and when we take the projection of this AB line on the vertical plane, this is A dash and B dash. So we have seen that this is enlarged in size. So it will depend upon the location of the light where the line is there. If the line is beyond the vertical plane, then we have taken the reduced projection on the vertical plane, and when the line is in front of the vertical plane, then we have taken the enlarged view. If the line itself lies in the vertical plane, then this length of the line or the length of the projection is same in that situation. So we have seen that in isometric projection, in perspective projection, and in oblique projection, in these three projections except orthographic projection, only one view is sufficient to represent the figure or to completely describe the object basically. While in the orthographic projection, we have taken two views at least or more than two views to completely show the different features or different dimension of the object. Now we are talking about the quadrant system. So there are four quadrant system. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So when we are putting the object into the first quadrant, means we are putting the object above HP and in front of the VP. So when this is the position of the object, we say it is in first quadrant. Similarly, when we are coming to the second quadrant system, so the object is placing above the HP and behind the VP. So this is the position of second quadrant. In the third quadrant, similarly, if we are putting the object below HP and behind VP, it is in third quadrant system. Similarly, when we are putting the object below HP and in front of the VP, it is in fourth quadrant system. So this is the quadrant system. So normally we follow the first and the third quadrant system. The first quadrant system is as per the BIS, Bureau of Indian Standards, and they recommend it. And the third quadrant system is normally used in the USA in other countries as such. So there should be a slight difference between the first and the third quadrant. As we see that if the object is placed in first quadrant, it is a first quadrant system, or method of projection, and when we are putting the object into the third quadrant, then it is called as the third angle projection method basically. So the second difference is here in the first quadrant, the object is in between the plane of projection and the observer. Okay. While in the third quadrant system, the plane is between the observer and the object. This is the only difference. The other difference is in the first quadrant system, we are assuming that the plane of projection, either VP or HP, they are non-transparent basically. And in third quadrant system, we have assumed that the plane of projection are transparent, because when we assume they are transparent, even then we have taken the projection of the object into these planes basically, HP or VP. So here if we are putting the object into the first quadrant, so this is a three-dimensional pictorial representation, but we have to, on the drawing sheet, we have to represent that into the 2D. So what we are doing, so you see that they are marked as A, B, and the directions are also marked. So whenever we are taking the projection of any of the object in the first quadrant system, so either we rotate the vertical plane into the anti-clockwise direction by an angle of 90 degree. So when we are doing this, then HP and VP are in the same plane. Or the other way is we rotate the HP by in the clockwise direction by an angle of 90 degree, so that both VP and HP are in the same plane. Means they are representing the projection of the object into the on the plane sheet, on the plane drawing sheet. Similarly, when we are putting the object into the third quadrant, then we rotate this HP. Okay, it is marked as B by an angle of 90 degree in the clockwise direction. So in that situation, the both VP and HP are in the same plane, or we can rotate this vertical plane, okay, by an angle of 90 degree into the direction as marked as a in the anti-clockwise direction. So in that situation, this both HP and VP are in the same plane. So this way we can represent the projection of any of the object into the first and third quadrant onto the drawing sheet. Here let us understand the first angle projection in more detail. So here this is the object and the relative position of different views: RHS view, right hand side view, left hand side view, front view, bottom view, top view, and back side views are shown in the figure. This is the first figure is a three-dimensional projection of any of the object onto the different planes, and the second one will show you the different position of the projections onto the two-dimensional sheet. So let us understand it clearly. So suppose this is the object which we are placing in the first quadrant, means the object is placed in front of the VP. This is VP in front of the VP and above the SP. So this is the means the object is kept in the first quadrant. And we assumed here in the orthographic projection that the rays are falling on this object from the infinite, so that all the projectors are parallel to each other and they are intersecting at an angle of 90 degree with the vertical plane. So when we viewed from this side, so we are getting a front view, and this front view will be here. Basically this is the position of the front view. If we are seeing from the top side, so we are getting the top view on the HP basically. When you see it from the bottom side, so we are getting a bottom view on the top one. When we are viewing from the left hand side view, when we are viewing from this side, we are getting a left side view on the right side basically of the object. And when we are viewing from the right side, then we are getting a view on the left hand side that is called as RHSV, means right hand side view. When we are seeing from the back side, we are getting a back side view. This is shown here in front of the object basically. So this is the different positions of the different projections with respect to the object and the front view. Now if we are coming to the two-dimensional sheet, so first of all we draw the front view. If we draw the bottom view, the bottom view will be come above the front view, and the top view will come below the front view. The right hand side view will be coming on the left side, that is called as RHSV when we are viewing from the right hand side. So this is called the RHSV, but this is on the left of the front side. Similarly LHSV, this is called the left hand side view. This is coming out to be the right side of the front view when we are viewing from the left side. So when we are viewing from the left side, we are getting a view on the right side, that is LHSV. When we are viewing from the right side, we are getting a view on the left plane, that is called the RHSV. In all the cases, the position of the back view is always right to the LHSV in case of the first angle projection basically. So these shows the position of the different views with respect to the front view in the first angle of projection. Here we are studying the third angle of projection in more detail. So this is the third angle projection. We assume that the object is kept to the third quadrant. This means this object is putting below the HP and behind the VP. This is VP and the object is putting behind the VP. And we assume that the observer is at an infinite distance, so that all the rays falling on the object are parallel, means the projectors are parallel and they are inclined at an angle of 90 degree with the different plane of projection. We also assume that all the planes are transparent. So when we are viewing from the infinite, and we assume that this is the transparent plane, and behind that plane the object is kept, means the plane of projection is in between the observer and the object. So we are getting the front view here on the front side. When we are viewing from the left side, so we are getting a left side view. When we are viewing from the right hand side, we are getting a right hand side view. So we see that left hand side view will be on the left side of the object and right hand side view will be on the right hand side of the object. When we are from the back side, so back side view will be on the behind the object. When you see from the top side, the top side view will be on the top faces, and when we see from the bottom side, so we are getting a bottom view. Means from which side we are seeing, on the same side we are drawing the view in the third angle projection. So this is a three-dimensional views or projection representation of any of the object. In the two-dimensional, if we see, The front view we will draw in midway, as we are drawing in the first angular projection. When we are viewing from the top side, so top side will be on the top one. Okay? When we are viewing from the bottom side, the bottom view will be on the below to the front view. Means the top view will be on the upside uh, with respect to the front view, and this bottom view will be on the downside basically. When we are viewing from the left side, so we are getting a left hand side view. When we are viewing from the right hand, we are getting a right hand side view. So the position of left hand side will be on the left side of the front view, and the position of the right hand side view will be on the right of the front view. Top side will be on the top side, and bottom will be on the bottom side, and front will be in the middle basically. Back side view will be always towards the right of the right hand side view in case of the third angle projection. So this way we see that how we can draw the projection of any of the object into the third angle projection. This angular projection normally refer in USA and other countries. This diagram shows the symbolic representation of the first and third angle projection. So first will represent the first angle projection, and second will represent the third angle projection. So on the drawing sheet in the title box we have one space where we are showing the symbolic representation of first and third angle projection. So here we have taken the frustum of cone, and when we are viewing from this side we are getting a front view of the object, and when we are viewing from the left hand side we are getting a left hand side view. So the front view position will be in middle basically, as we have seen in the previous cases of the first angle projection. And when we are viewing from the left hand side view, so we are getting the two concentric circles. So smaller one as well as the bigger one basically, and both are concentric with each other. But the position of the left hand side view, as we have seen, that it is right to the front view basically in the first angle projection. In the third angle projection, we have taken the same object and we are taking the left hand side view. So the left hand side view will be on the left side and as compared to the front view basically in the third angle projection. So when we draw these final views on the drawing sheet, so it is clear that in which angular projection this drawing is normally made basically. So it is must to represent either first angle projection and third angle projection. The first angle projection is normally referred by BIS, Bureau of Indian Standards basically, and this third angle projection is normally used in USA in other part of the country. Here in this video we understand the concept of projections. The first and third angular projection we have seen, and we have seen that the position of the different views in first and third angle projection with respect to the front view. If you like this video, please like, subscribe, share and comment. Thank you.